Welcome back to the third 9-week benchmark review. We are going to go on to equations and expressions. We're going to start with one, which is, there's 3 problems in it. Let's take a look at them, 40, 47, and 68. You can always pause at any time and try these for yourself before you hit play again. Number 40. I lost myself already. Number 40. I tried using different colors so I could see them better. Alright, number 40. Which expression is equivalent to negative 3 times 2x minus 2 minus x plus 3? Oof, there's letters in it now. That throws some folks off, but it's okay. We're going to have to do some distributing, and it might be beneficial to talk with algebra tiles this week and get set up with learning how to do that, how to conceptualize this. So one thing you could do if you wanted to is you could pick a value for x, something that's not 1 or 0, because sometimes that'll mess you up. Pick a value for x and then plug it in and test it. Like if you put 2 in, then what you do is 2 times 2, which is 4, minus 2, that's 2, times negative 3, that's negative 6. And then you're going to subtract whatever 2 plus 3 is, which is 5. I get negative 11, and then you go through and say, okay, which of these works out to be negative 11? Negative 7 times 2 is negative 14 plus 3. That one would be it, because that would also be negative 11. But let's do the algebra and see what it looks like. I have stuff in parentheses. Order of operations says I gotta deal with that first. But I cannot combine x plus 3 into one term because x is an unknown and 3 is a constant. If x is an unknown, a variable, 3 is a constant. I can't push them together into one term unless I'm multiplying or dividing stuff. If I'm adding, I can't push them together. So same thing with this one, 2x minus 2. I can't make that any simpler with no value for x. So we're going to have to go ahead and start multiplying. And we're going to use the distributive property because I have negative 3 times 2 things in my parentheses. Negative 3, since it's negative, it's going to change the sign of this term. This first term will be negative. It's going to change the sign here. It's going to be a plus sign in between them. All right, what's negative 3 times 2? That's negative 6. I'm going to have my x with it because the x is there before. Negative 3 times a minus sign 2. I like to think of this, when I think about this stuff, I usually think of this negative as interchangeable, or this minus as interchangeable with a negative sign. It's the same thing. This inside piece is 2x plus a negative 2. So I can think of it as plus negative 2. And then I do negative 3 times negative 2. That's a positive. So I'm going to leave my positive there. Positive 3 times 2 is 6. And that's just unpacking this guy right here. Now I got to unpack this piece. I have a negative, and then I got a parenthesis with 2 pieces inside, 2 terms inside. This negative sign is going to change the sign of both this piece and that piece. So negative, it's like a negative 1 times x. So minus x. And negative 1 times positive 3 is a negative, or minus 3. Now that I've got a bunch of pieces, nothing's in parentheses or nothing else to multiply, I can do the adding and subtracting. So I've got to find similar terms. So I've got a variable term here, a variable term here, and the sign goes with it. Negative 6x and a negative x. It's like a negative 1x or a minus 1x. Negative 6 minus 1 is negative 7. You can also think I've got negative 6 pieces of x plus another negative 1 piece of x. Total negative 7x. Now I've got a positive 6 minus 3. 6 minus 3 is 3. There it is. Next is 47, which is down here. It's the same kind of thing. Again, you can pause now if you want to give it a try. We're going to be distributing first and then combining similar terms. Or you could pick a value of x and see what happens. Zero sometimes gives you good results. If I pick x equals 0, then everything with x in it can just be ignored, because 0 plus 5 is just 5, and 3 times 0 is 0. 0 minus 2 is just negative 2. You can see what's 2 times 5, that's 10, and minus negative 2, that's plus 2, that'll be 12. If I plug in 0 for x over here, the only one that gives me 12 is d, so I'm guessing it's d. Let's do the math and double check. Okay. Distributing, I've got a positive 2 out here, so it's just 2 times x. And 2 times this plus 5 is plus 10. I've got a minus sign right here. It's like a negative 1 times both these pieces. It's going to change my signs. So I'm going to have a minus sign, minus 3x. And minus sign, I'm going to change our sign here, plus 2. We're going to go again and we're going to take our x terms, put them together. I've got positive 2x and negative 3x. 2 minus 3 is negative 1x. We're off to a good start. That's the only way these start. The biggest thing we've got to figure out, and if you notice they're all the same, then you can just ignore the x's in general and look at what 2 times 5 and minus a negative 1 times a negative 2, what's that's going to be? Because we got plus 10 plus 2. 10 plus 2 is 12, and it's all positive. There we go. These other things, some of them are on here because, like, what if I'd forgotten to change my sign of this minus 2? And I had a minus 2. 10 minus 2 is 8. That would look like letter C. These distracting answers are here for a reason. What if I'd forgotten to double the 5? 5 minus negative 2 is 7. What if I'd forgotten to double the 5 and forgotten to change the sign of the negative 2? 5 minus 2 is 3. That's why those guys are on there. They're really trying to trick you. Really, really trying to trick you with this question. But you guys can get it. I have faith. Let's look at number 68 real quick. There it is. This is one of those fancy ones where you gotta pick a bunch of stuff. Yay. Equivalent expressions. Oof. There's a lot of work in this one. If you can narrow it down by doing a couple of the simple ones, you're going to be way ahead of the game. Almost all of these ones, like all these guys, require distributed property. These guys, like, you might need to notice that this minus here means I'm going to change my sign of both pieces in here. But all these ones are going to be combining similar terms. Chances are, if you have something like this, there's going to be like one in each row, one in each column. I can't guarantee it because I think the format's slightly different. So let's start doing some work. Let's take a look at how to do these distributions. Oh my goodness. Everything here is all fractions, so let's leave everything as a fraction. We're not going to worry about trying to simplify by turning it into decimals or anything like that. If I have negative 1/3 times x, that's negative 1/3 x. And then I have negative 1/3 times a plus 2. So I'm going to be changing, and not only did I change the sign here for this first term, it's a change in the sign for the second term. Minus 1/3 times 2 is 2/3. 1/3 of x is 1/3 x. 1/3 times positive 3. To multiply a whole number by a fraction, you can think of it as 3 over 1. And just do top times top, bottom times bottom. You get 3 divided by 3, or 3 over 3. That's just 1. If you put it in a calculator, you can always do times the top, divide by the bottom. So 3 times 1 is 3, divided by 3 is 1. You get 1/3 times 3x. Again, you got 1/3 times a 3. 3 times 1 is 3. 3 divided by 3 is 1, so it's just 1x. And then you have 1/3 times plus 1. That's, well, 1 times anything is just what you got, so 1/3. Alright, 2/3 times 3x. Okay, 3 times 2 is 6. 6 divided by 3 is 2. 2x. 2/3 times a negative 1 minus 2/3. Because 1 times anything is itself. Alright, I'm going to take a break and look at these guys. These guys are all combining like terms. These are the easier looking ones. They already been distributed. I don't have to worry about do I change my signs or not. I just look what I got. Here's a piece with x. There's a piece with x. 4/3 plus 2/3. 4 plus 2 is 6/3. 6/3 is 2x. I'm going to stop right there. Look, the only one that had 2x in it is this guy. Minus 2/3. Yep, that's the other piece I got. Boom, that's it. Here I have two constant pieces and one x piece. Hey, there's only one negative 1/3 x up here. I bet it's this guy. Let's check. A negative 4/3 plus 2/3. Negative 4 plus 2 is negative 2/3. There, that's it. Cool. Hey, look. Even if this stuff flummoxes me, I've already got two of them right. I got a 50-50 shot about picking these guys right. So let's take a look. I have 1/3 x here. I'm going to do the plus one first because it's easier. Plus 2/3 x. 1/3 plus 2/3. 1 plus 2 is 3. 3/3 is just 1x. There's only one of those. And then 2/3 plus negative 1/3, so that's 2 minus 1. That's 1/3. Yeah, that's right. We can double check we did it right. 2/3 of x minus 1/3 of x. 2 minus 1 is 1/3 x, and I've got one of those. 2/3 minus negative 1/3. That's like 2/3 plus 1/3. That will give us 3/3, which is 1. So you don't necessarily even have to do all the math. I just found the x term, since they were all different, I didn't even have to worry about the constant term. That's something to think about for taking a shortcut sometimes. Save you some time on a problem that looks like it's got a lot of work to do.